Hello students, today we can discuss the questions from RE NEET physics paper. First question, a photon and electron each of 20 electron volt energy move in free space. The ratio of linear momentum of electron to that of photon is. So, linear momentum of electron momentum is equal to, we can directly write, kinetic energy p square by 2m. So, momentum is equal to root of 2m into energy. Similarly, what is the momentum of photon? Momentum of photon is equal to what we studied E by C. E by C. So, ഇതോടെ ratio தான் നമുക്ക് വേണം. So, taking the ratio students. Therefore, P by PP is equal to, on taking the ratio, C will go to the numerator. So, root E by E will become 1 by root E. So, C into root of 2M by E. Okay. So which is equal to, what is C value? 3 into 10 power 8 into root of 2 into what is mass of electron which is given in the question? 9 into 10 power minus 31 divided by E. E value is 20 electron volt. So 20 into 1.6 into 10 power minus 19 joule. You have to convert into joule. So on solving this, you will be getting the right answer directly. You will be getting 225 students. So fourth option will be the right answer. Second question, water flows in a streamline motion through a horizontal pipe of circular cross section as shown in the figure. The pressure difference of water between P and Q is 15 Newton per meter square. The area of cross section of P and Q are 40 centimeter square and 20 centimeter square respectively. The rate of flow of water through pipe in centimeter cube per second is, take density of water is equal to 1000 kilogram per meter cube. So we have to apply equation of continuity and Bernoulli's principle together to do this question. So we required rate of flow means rate of flow is equal to what? Area into velocity, that is AP VP, either you have to find, or AQ VQ. It's up to you students. என்ன find பண்ணாலும் உங்களுக்கு ஒரே answer தான் வரும். Because according to equation of continuity, AP VP is equal to AQ VQ also, that is called as rate of flow. So applying Bernoulli's principle at A and B, this I am calling as first equation students. P and Q. Apply by Bernoulli's principle at P and Q. Pressure at P plus half rho into, let velocity at P I am calling as VP, area of P I am calling as AP, velocity at Q I am calling as VQ, area at Q I am calling as AQ students. So half rho into, here it will become VP square is equal to, it's a horizontal pipe, so that potential energy per unit volume on the both side will be cancelled. That's why I am not writing that term here. Is equal to pressure at Q plus half rho into what? VQ square. Right. So I can write, students, therefore PP minus PQ is equal to half rho into VQ square minus VP square. You will be getting VQ square minus VP square. VQ square minus VP square. Right. Which is equal to, what is pressure difference which is given in the question? Pressure difference between P and Q, 15. Therefore 15 is equal to half into density is 10 power 3000. VQ, I don't know VQ and VP, so you can have to change the VQ in terms of VP students. So what is VQ? I can write VQ is equal to AP VP by AQ. So that square the AP by AQ whole square into VP square you will be getting, right? So what will be AP by AQ? AP by AQ, AP is 40, AQ is 20. So AP by AQ will become 40 by 22 VP the whole square minus VP square. You can write like this. Therefore 30 is equal to, I just multiply to LHS, 10 power 3 into 4 VP square, VP square 3 VP square. So you can cancel 3 and 30 get cancelled, and this 0 cut 1 sorry 2. So VP square is equal to 10 power minus 2 gives Vp is equal to 10 power minus 1 meter per second, which is equal to 10 centimeter per second. Therefore, rate of flow Q is equal to APVP. What is AP value? 40 centimeter square. What is VP value? 10 centimeter per second. So 400 centimeter cube per second. So the right answer is first option. First option will be the right answer. Next question. A thin horizontal disk is rotating about a vertical axis passing through its fixed center O. Its angular momentum is LA and LB computed about the points A and B. Respectively, OB is equal to 2 into OA. The value of LA by LB. So it is very clear that it is a pure rotational motion, right? Because it is just rotating about a point, there is no translation. So it will not be having any angular momentum with respect to due to the motion of center of mass. Center of mass is at O itself. So it is only having what rotational angular momentum. That is due to rotational motion, which is equal to I omega. So I is constant and it is rotating at a constant speed also. So I omega will be same, angular momentum I omega will be same in both the cases, LA and LB. LA and LB will be is equal to what itself, I omega. So what will be the ratio? 1:1. Fourth option will be the right answer. Next question. Fourth question. Consider a long solenoid of length L, radius R. If small n is the number of turns per unit length and mu naught is the permeability of free space, the inductance of the solenoid. It's a direct question. We know inductance of solenoid mu is L is equal to mu naught n square area into length of the solenoid. This is the direct equation. But they didn't give an area. Instead, we have to substitute what is area, students? Pi r square, like pi r square into L. So, which is the right answer? Just by checking the options, you will be getting second option as the right answer. Option 2 will be our right answer. Next question. Question number 5. The temperature of a metallic sphere of radius capital R increased by a small amount delta T. If the linear coefficient of thermal expansion of metal is alpha, then the approximate increase in the volume of sphere is. It is direct question. Volume of the sphere increase means delta V be required. So we know delta V by V is equal to what we studied, gamma delta T. So approximate change in volume, that is delta V is equal to V gamma delta T. So what is the volume of a sphere? What is the volume of a sphere, students? 4 by 3 pi r cube. Gamma illa but question alpha terms il namakku venam ille. Appo gamma is equal to 3 alpha into delta T. So you got the answer. 3 get to cancel. Therefore delta V is equal to 4 pi r cube into delta T. 4 pi r cube alpha delta T. Fourth option will be the right answer. Fourth option. Next question. Consider two circuits A and B, each of having two resistors. One of them has a positive temperature coefficient of resistance plus alpha, while the other one has a negative temperature of coefficient minus alpha as shown in the figure. The current through these circuits are denoted by IA and IB. At the initial temperature, the resistance of two resistance is R0. As the temperature is increased, the correct option that describe the variation of current in these circuits is. So it is very clear that first one is having a this is 1 minus alpha means it is having a negative temperature coefficient. Second one is having a positive, anyway 2. So on increasing temperature, for example, if temperature is increased, current increase in if temperature is increased, first one order resistance decrease second one order resistance now increase but the same alpha adinal decrease increase okay. So what is in series R effective is equal R1 plus R2. Now decrease increase such that net resistance change first case current will be what IA will be what only same only change IA will be same. But in second question, you know that parallel connection automatically iroda resistance decrease equal resistance will be less than this one. Smallest one or lowest equivalent equivalent current in the second B circuit IB will be what increase so IA remains constant while IB and I students increases. Second option will be the right answer. Next question. It's an easy question. A beam of light falls on a metal surface such that photoelectrons are generated. If the power of the light source start to decrease linearly with respect to time t, then variation of photocurrent and magnitude of stopping potential with the time is best represented by. So you know that when power decreases, intensity decreases. Intensity decreases means current should be decreasing. Current should be decreasing. Okay, but stopping potential is independent of intensity. So second option. Second option will be the right answer. Seventh question. Option 2 will be our right answer. Now question number 8 students. Question number 8. An ideal Zener diode with a breakdown voltage minus 3 volt photoactive will breakdown arm is reverse biased with a negative input voltage minus 5 volt. Then the magnitude of voltage difference between point B and it is will be what നിങ്ങളെ പറ Zener diode വിட അധികമാണ് voltage ഇരുന്ന Zenerൽ 3 volt പോ remaining 2 volt தான் இங்க വരും. ഇപ്പോൾ for example അപ്പോൾ answer will be 2 volt. Okay. If less than Zener voltage, the voltage potential difference across resistor will be what 0 only. If the applied voltage less than Zener voltage, voltage across resistor becomes 0. But here it is greater than Zener voltage, so voltage across the resistor will be 5 minus 3 will be is equal to 2 volt. Third option. Next question. In the measurement of viscosity of liquid using terminal velocity experiment, a spherical ball of same radius but having different density are used. The variation of terminal velocity with the ratio of density of spherical ball to the density of the liquid is. So here, what is terminal velocity equation? Terminal velocity is equal to 2 by 9 eta r square g into density of the spherical ball, that is sigma, minus density of the liquid. Right. So I needed a graph connecting V versus ratio of density of spherical ball to liquid. That ratio I have to make. So V is equal to 2 by 9 eta r square g into, I am just taking density of the liquid outside. So sigma by rho minus 1. Sigma by rho minus 1. So it is very clear that 2 by 9 constant, coefficient of viscosity constant, radius of the ball constant, g constant, density of the liquid constant. So V is equal to K into sigma by rho minus 1, which is of the form y is equal to, sorry, this is which is equal to, I am just writing again, K sigma by rho minus K. V is equal to K into sigma by rho minus K, which is of the form y is equal to what, students? Mx plus c, right? So on y-axis, you should be having what, students? Y-axis velocity. On x-axis sigma by rho, slope positive slope but negative y-intercept. Negative y-intercept minus k start ആവണം positive slope. So the right answer will be second option. ഇത് extend பண்ணாத இங்க வரும். Understand? Second option will be the right answer. 9th question. Option 2. Question number 10, students. Simple question. Two planets P1 and P2 with equal mass have radii R1 and R2 respectively. R2 is equal to R1 by R2, where R2 is equal to R1 by R2. The escape speed of P1 and P2 are V1 and V2 respectively. Then V2 by V1 is. So it is very clear. Question equal mass to question. So what is escape velocity equation? Root of 2gm by R. Why I choose this equation? G constant, mass same question. The equation. So what will be V2 by V1? Therefore V2 by V1 is equal to root of R1 by R2 because they are inversely proportional. So which is equal to root of what is R1 value? R1 is R itself. R1 and R2 is equal to R1 by 2. So R1 get cancelled. So root 2. Fourth option will be the right answer. Fourth option. Question number 11, students. In AC voltage V is equal to 200 sine 2 into 10 power 3 t. 2 into 10 power 3 is omega is applied across a series LCR circuit. Then the current amplitude. So current amplitude is equal to voltage amplitude by impedance. Impedance model find pannadukku XL XC ellam venam. So model XL find pandra. XL is equal to what is the equation? Omega L. So what is omega value? 2 into 10 power 3 into what is L value, students, which is given in the question? 10 millihenry, 10 into 10 power minus 3, that is 10 power minus 2. So it is equal to 20 ohm. XL is equal to 20 ohm. Next, XC is equal to 1 by omega C. So 1 by 2 into 10 power 3 into what is C value? 25 microfarad, 10 power minus 6. So which is equal to 10 power minus 3 minus 3 വരും നെറ്റിലെ ഡിനോമിനേറ്ററിൽ അത് മേലെ പോകുമ്പോൾ 10 power 3 ആകും, that is 1000 by 50 which is equal also 20 ohm. So XL is equal to XC. Circuit is under which condition, students? Resonance condition. அப்படியான peak value of current is equal I naught is equal to V naught by R because XL is equal to what? XC. രണ്ട് equal ആയിരിക്കും. So what is V naught value? 220 by what is resistance? 100. So answer is 2.2 ampere. Right answer is 2.2 ampere. That is answer for 11th question. Second option. Okay. Next question. Question number 12, students. Two identical inductors are connected in different configurations P and Q, where a time varying current I of t is flowing as shown in the figure. The induced EMF between points A and B for configuration P is EP and that for configuration Q is EQ. The ratio EP by EQ is. So it's a simple idea. You are confused பண்ணதுக்கு இங்க ஒரு hint இருக்கு. Listen. Here it is A, here it is B. Here it is A, here it is B. So இதுக்கு across inductor L தான், இதுக்கு across ரெண்டுக்கும் ஒரே potential difference, inductance is L, ஏதாச்சும் ஒன்று find பண்ணா போதும். So induced EMF is directly proportional to what? Current change லே, rate of change of current. Okay. So இங்க முதல்ல ஒரு current வருது, பட் இங்க பார்க்கும்போது முதல்ல என்ன current வருதோ, இப்போ இங்க I of t வந்தா இங்க I of t by 2 தான் இதில் வரும். அப்போ அதுக்கு proportional induced EMF by 2 ஆயிடும். So here for example, first case ல across A and B in induced EMF in P case is equal to E ആണ്. Induced EMF in Q case will be is equal എന്ന് വരും E by 2 എന്ന് വരും. Because why? Current through that inductor is getting halved. Current. So what will be the ratio? Ratio എടുക്കുമ്പോൾ E cut off. So 2 will go to the numerator 2. First option will be our right answer. First option. Question number 13, students. Three identical capacitors P, Q and S, each of capacitance C are connected to a battery of voltage capital V as shown in the figure. The energy stored in the capacitor P and total energy stored in the system are UP and UT respectively. Then the ratio of UP and UT. So it is very clear. Here applied voltage is V. So that V, P and Q are having same capacitance means idukku across V by 2 irukkum, idukku across V by 2 irukkum. Here will be V itself because parallel connection, parallel ആണ്. என்ன voltage ഇരിക്കും അതേ voltage ഇതൊക്കെ across വരും. So upper branch V by 2 split out. Right. So what is the potential energy of P, students? Half into C into V square. So what is V across P? V by 2 whole square. So another answer it will become 1 by 8 CV square. 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 Okay, students. 1 by 8 CV square. Next, what is total energy? ಅದಕ್ಕೆ என்ன வேணும்? C equivalent வேணும். So C equivalent is equal to, you can see that these two are series. அப்ப C series ആണ്, C by 2 ആവും. അത് C by 2 இந்த C യും parallel. அப்ப என்ன வரும்? Parallel ആണ്, equivalent will be C by 2 plus C which is equal to what? 3C by 2. Therefore, the total energy density is equal to half into C equivalent into V square. So half into what is C equivalent value? 3C by 2 into V square which is equal to 3 by 4 CV square. Therefore, take the ratio of the both equation. Therefore taking the ratio, therefore UP by UT ഇതാണ് നമുക്ക് വേണം. അപ്പോൾ യാരെല്ലാം കട്ട് ആവും സ്റ്റുഡൻസ്? CV square കട്ട് ആവും. റിമൈനിങ് ഇങ്ക 1 by 8 divided by 3 by 4. So you can get you will be getting 1 by 8 into 4 by 3. So inga 2 ആകും. So answer is 1 by 6. First option is our right answer. First option is our right answer. Next question. Question number 13 already we discussed. Now question number 14, students. A conducting loop of finite resistance lies on XY plane. There is a constant magnetic field in the Z direction. Magnetic field is constant. The area of the loop varies with the time t. Varies with the time t as A is equal to A naught into 1 plus sin t in approximate units. The figure that correctly indicates the qualitative behavior of the power dissipated in the loop. So it is very clear induced EMF is due to why it is inducing EMF in the exchange area. So induced EMF is directly proportional to d phi by dt in theory. This is directly proportional to area than change magnetic field constant. So dA by dt. Right. So dA by dt what is dA by dt? A naught constant 1 plus sin omega t, A naught into 1 plus sin omega t differentiating, you will be getting A naught into cos omega t. Induced EMF A naught to cos omega t proportional. So what is the power dissipated? Power is equal to E square by R. So power is proportional to E square, which is proportional to A naught square cos square omega t. So cos square function graph cos function graph students cos graph right, sorry, cos cos 0 cos 0 peak start graph but the cos square means the cos function, the cos theta graph. So cos square theta students the negative value negative value positive, negative square positive cycles. But we have to start from the peak value. So third option, because it is a cos function. Okay. So third option is our right answer. Question number 15. In the adiabatic expansion, the temperature of 1 mole of an ideal monoatomic gas gamma is equal to 5 by 3 decreased from 60 Kelvin to 50 Kelvin. The work done by the gas in this process is, it's a direct formula. Work done in adiabatic process is equal to NR by gamma minus 1 into T1 minus T2. Direct equation. Every value is given in the question. So number of moles is equal to 1, R is equal to 8.3, gamma minus 1. 5 by 3 minus 1 will become 2 by 3 into T1 minus T2. What is T1 minus T2? 10 Kelvin. 10. It's 60 minus 50. Right. So I will be getting 83 into 3. 83 into 3 by 2. 83 into 3 by 2. What will be the answer? You will be getting the correct answer as 124.5 joule. Fourth option will be our right answer. Okay, students, fourth option.
Coming to question number 16. Consider a particle moving along a straight line whose position as a function of time is given by S of t is equal to alpha t square minus beta t plus gamma, where alpha is equal to 1 meter per second square, beta is equal to 6 meter per second, and gamma is equal to 5 meter. Now the average speed of the particle in meter per second from t is equal to 0 to t is equal to 6 seconds. So regarding this question, we have to be very careful because the given equation is displacement and they are asking you average speed. So what we have to check is whether there is any point where the body will have a velocity 0. Because if the body come to momentary rest, then you know the body will retrace the path. In that situation, displacement and distance are different. So that is what first thing we should verify. So it is given that S of t is equal to alpha t square minus beta t plus gamma. So V of t is equal to the derivative of the position ds by dt. So you will get it as 2 alpha t minus beta, right? Now let's equate it to 0 so that for me t is equal to beta by 2 alpha. Let's substitute. Beta is 6 and 2 alpha is 2 into 1. So this is 3 seconds, which means the body come to a momentary rest at time is equal to 3 seconds. So after that there is a possibility body will retrace. Okay. So from time is equal to 0 seconds to time is equal to 3 seconds, we have to find the distance. For that, let's find out the displacement at t is equal to 0. This displacement will be equal to gamma, which is 5. Now let's find out the displacement when time is equal to 3 seconds. That will be alpha t square. What will be alpha t square? Alpha is 1. So 1 into t square is 9 minus beta t, that is 6 into 3, that is 18, then plus 5. So this is actually minus 4. Okay, so what is the distance here? How to find the distance? Distance will be equal to minus 4 minus 5, that will give me 9. So that is the distance. Now time is equal to 3 seconds to time is equal to 6 seconds. Okay, similarly you try to find it. You will get the distance is equal to same 9 meter. So you know the average speed. Okay, speed average. What is the equation? Total distance by total time. So total distance is 9 plus 9 and total time available is 6. So 18 by 6 will give you answer as 3. So the answer is actually option 4. Now coming to question number 17. This is one of the simplest question. Okay, the following table presents the part of the electromagnetic spectrum and their corresponding major application. See, microwave, you know microwave is for warming the food. UV rays, you know in water purifier we are using. Gamma rays are for treating the cancer cells, and radio wave for AM and FM communication systems, correct? So P2, Q1, R4 and S3. Yes, it's option 4. Okay. Now coming to the next question. An ideal gas is made of polyatomic molecules. Each of the molecule has a 3 translational degree, 3 rotational degree, F number of vibrational mode. If the ratio of heat capacity Cp by Cv, that is gamma, is equal to 8 by 7, then the value of F, see you know gamma is equal to 1 plus 2 by F. So let's substitute. 8 by 7 is equal to 1 plus 2 by F. So I can tell 1 by 7 is equal to 2 by F. So F is equal to 14. Now in this 14, 3 is for translation, 3 is for rotation, and so what is the remaining? 3, 3, 6. Now 8 is there, 8 is for vibration. Now what will be the degree, vibrational degree? You know for each vibrational degree, okay, for each vibration we count 2 degree of freedom, right? So I can tell it will be 4 vibrations, 4 vibrational mode, 4 vibrational mode. So it will be option 2. Now going to the next question. Question number 19. A unit positive point charge is taken slowly through an infinitesimally thin tube that is inside a charged dielectric sphere of radius capital R, having uniform positive charge density rho as shown in the figure. The initial and final position of the charge are marked by A and B at distance 2r and 3r respectively from the center of the sphere. In this process, the magnitude of total work done on the point charge is rho r square by n epsilon naught. The value of n is. So you are asked to find the value of n, right? So this question doesn't specify anything about the kinetic energy. So I can simply tell the work done will be equal to change in the potential energy, which is potential energy final minus potential energy initial, isn't it? Now how will I find the potential energy? See, in order to find the potential energy, you know the equation for potential energy is K Q1 Q2 by R. Okay, but it is a unit positive charge, so I can simply write this as, suppose this is the unit positive charge 1 coulomb. Okay, then I can simply write this as K Q by R, isn't it? K Q by R, where this is for the sphere. Agree. So this can be written as K. How can I write Q? You know, the volume charge density is given as rho. So Q can be written as rho into 4 by 3 pi r cube. Okay. Divided by small r. Now you know the expansion of K. K is 1 by 4 pi epsilon naught. What if we substitute that? You will get it as rho r cube divided by, okay, there will be one 3 here, right? Okay, 4 by 3. Volume is 4 by 3 pi r cube by 3r. So you got the equation for the potential energy. Now just apply the equation. What is the U final? U final is rho r cube divided by 3 into, what is the distance? Small r is, here it is 3r. So 3r minus rho r cube by 3 into, what is this distance? Again small r, which is 2r. So this can be written as rho r cube by 3r into 1 by 3 minus 1 by 2. So what you get? Rho r cube, okay, minus rho r cube divided by 3 into 2 is 6, again into 3, that is 18. One epsilon naught is there, right? Okay, I have missed one epsilon naught. Here will be one epsilon naught, right? Okay, that's it. One epsilon naught will be there. So what is the n value? The question is regarding the n value. So the n value is actually 18. So which is option 1. Okay, hope you understood this question. Now let's move on to the next question. A current I0 flow through a metallic circular loop of radius r as shown in the figure. The resistance of the segment ABC, okay, resistance of the segment ABC is actually half the resistance of ADC. Okay, so magnitude of magnetic field at the center of the loop is, that is what I am asked to find, right? So what is the radius of ADC? Sorry, resistance of ADC. Suppose if I take resistance of ADC as R, then ABC will be equal to R by 2. Then automatically I can tell here through ABC, okay, what will be the current? Current of ABC, that will be equal to 2 I naught by 3, right? 2 I naught by 3. And what will be the current through ADC? It will be I naught by 3. Now I want to find the magnetic field, right? So if I am trying to find the magnetic field, okay, then magnetic field of ABC, magnetic field of ABC will be equal to mu naught. It's a semicircle, right? So mu naught I, okay, 2 will be there, 3 will be at the bottom. You know, equation is mu naught I by 4r, right? Into 4r will come. Okay. Now what if I try to find the magnetic field of ADC? Now what will be the direction? You know how to find the direction, right? For this the direction will be out of the page. Okay. Now magnetic field of ADC will be mu naught I by 3 into 4r. It will be into the page. Okay. So what will be the net magnetic field? Net magnetic field, both are in opposite direction. So if I call this as B1 and I call this as B2, so it will be simply B1 minus B2, isn't it? What if you subtract? If you subtract, you will get mu naught I by 12r. So mu naught I by 12r. So what is the option? Option 2. Now coming to the next question. There is a bob B of mass m at rest. is hanging vertically from the ceiling via a massless string of length 10 meter as shown in figure. Point mass A of mass m traveling horizontally with speed 10 meter per second hits the bob B elastically. Now the bob B rises h meter after the collision. Taking acceleration due to gravity, g is equal to 10 meter per second square, and neglecting the size of the bob, the value of h is. See, first of all, it is an elastic collision. Yes, elastic collision. So you know what is going to happen. They both are same mass, and B was initially at rest. So when they collide, you have learned that the velocity of A will go to B. That is, A will come to rest and B will start moving. So the B get a velocity which is equal to 10 meter per second. Now I need to know to what height will it rise. To what height will it rise? Okay. I want to know this height to which it will rise. Then you have learned the equation v square minus u square is equal to minus 2gh. So if I apply this, at this point the final velocity will be 0 only. So 0 minus 10 square is equal to 2 into 10 into h. Okay. So what you are going to get, this minus and minus will cancel. So that h is equal to 5 meter. Okay. So what is your option? Option 4. Now coming to question number 22. An electromagnetic wave traveling in a lossless dielectric medium having dielectric constant epsilon r equal to 9 has the electric field Ex equal to E naught sine kz minus 2 pi into 10 power 60 volt per meter, where E naught is the amplitude and k is the wave vector. Among the following, choose the incorrect choice. Very careful. Incorrect choice we have to find. So what about the first one? The direction of propagation of the electromagnetic wave is along plus z. Is that correct or not? Yes, it is correct. Why that is correct? Because you can see here one term is positive, other term is negative. So it will be, and here it is z only. So it will be traveling in positive z direction. So that is correct only. This is correct option. This correct means the statement is correct. Now next, the speed of the electromagnetic wave inside the medium is 10 power 8. You know the speed. How to find the speed? 1 by root of mu into epsilon. So if you substitute this, mu remains mu naught because it's a lossless medium. So it is mu naught epsilon r epsilon naught. So this is 1. This can be written as 3 into 10 power 8 by root of epsilon r, which is 3 into 10 power 8 by root 9. So root 9 and 3 cancels, you get 10 power 8. Yes, second statement is also correct statement only. Now what about the third statement? The wavelength of the electromagnetic wave. You are asked to find the wavelength. So first of all, you should know what is the frequency, right? So how to get the frequency? Frequency can be found as omega by 2 pi. Now from where I will get the omega? Omega is 2 pi into 10 power 6 from the equation divided by 2 pi. So this is 10 power 6. Now V is equal to F lambda. So lambda is equal to V by F. So what is V? 10 power 8. And what is F? 10 power 6. So what you get? 100. But what they have given is 300 meters. So we are asked to choose incorrect choice only, right? So incorrect choice. Which is the incorrect choice? I can tell you here, incorrect choice is option 3. All other choices are correct, right? What about fourth one? That is also, you know, B naught V by sin kz minus 2 pi into 10 power 60. That is also correct only. So 1, 2, 4 are correct statement. Third is the incorrect statement. Questioner asks what is the incorrect choice? Incorrect choice is option 3. Okay, hope you got the answer. Now moving to the next question. See, the next question is, a particle of mass capital M move along the horizontal x-axis from x equal to 0 to x equal to L. So there is a particle whose mass is m. It moves along x-axis from x equal to 0 to a point x equal to L. Okay, the coefficient of kinetic friction varies as a function x. Okay, so we have a varying mu, right? Varying mu, what is that? That is some equations like, mu k is equal to mu naught minus alpha x. Okay, where mu naught and alpha are constant, fine, of appropriate dimension, so that mu k of L. So when reaching here, your mu value becomes 0. So what will be the mu value at the starting? How will I find the mu value at the starting? Yes, substitute x equal to 0. If x equal to 0, then mu k is equal to mu naught. So this is mu naught. And what kind of a variation is this? Okay, it's a linear variation. So I can tell mu average is equal to mu naught plus 0 by 2. So mu naught by 2. That is the average. Okay. Now the question is, the total work done by the frictional force during the motion is given here. Okay, where g is the acceleration due to gravity. The value of n you are asked to find. When the body move to the right side, the frictional force will act to the left side. Okay, so that frictional force, how will I find that frictional force? Yes, it is mu m g into distance. Okay, it will be negative, that I know. The work done will be negative. Okay, but we need only the value of n, right? So our concentration should be at that point only. So it is mu naught m g L divided by 2. So what is n here? N is 1 by 2. So it will be option 1. Okay, so this is an easy way of approaching. You can go with integration also, but that will be a bit time consuming. Since it's linear variation, we can find the average. That is more simple. Okay, now let's go to question number 24. You are asked to consider 3 media, which is P, Q, R, with refractive indices 1, 1.25 and 1.5 respectively. The medium Q, having a thickness of 5 centimeter, is placed between extended media P and R as shown in the figure. An object O is placed at the center of the medium Q. If viewed from medium P near the normal direction, the apparent depth of O is h1. For the similar observation from medium R, the apparent depth is h2. The value of magnitude of h1 minus h2 in centimeter is. Okay, so it's a simple question of ray optics. Okay, how to get h1? See, when you are looking from here, okay, you are looking from rarer medium into a denser medium. So what can you tell? How to find h1? The equation is d apparent is equal to d actual by mu. What is d actual? Even though this is 5 centimeter, see, even though this is 5 centimeter, this is at 2.5 centimeter, isn't it? So actually is 2.5. Actually is 2.5. Now what is the refractive index in the figure? Refractive index is 1.25. So if you substitute 1.25, then this is 2 centimeters. So that is what h1. So h1 is equal to 2 centimeter. You got it. Now when you are viewing from this medium, okay, when you are looking from this medium, now you know that this is rarer and this is denser. So you are looking from denser to a rarer medium. So what is the equation you have to apply, okay, to find h2? I think this will be the point where students are going to make some kind of mistakes. Okay, so this can be written as d apparent is equal to mu times of d actual. Okay, now how to get mu? Mu is denser by rarer. Denser is 1.5 and rarer is 1.25. In short, it is 6 by 5. So it is 6 by 5 into 2.5. So that is 6 by 2 is equal to 3 centimeters. The magnitude of h1 minus h2, that will be 2 minus 3, right? So that is 1. So what is your right option? The right option is option 3, which is 1. Okay. Now going to 25th question. Consider a fixed uniformly charged insulating sphere. Okay, so you have a insulating sphere. Okay, now this sphere, I can tell this sphere have a radius r and charge is q. Now what happened? There is a point charge minus q with mass small m, okay, is released from rest at a distance 3r from the center. So from distance 3r you are releasing a charge which is minus q. Okay, when the point charge reaches the surface of the sphere, now when this charge, it will start to travel, yes, and this will reach at the center, that is over here it will reach, right? Okay, at the surface it will reach, okay, from the center of the charged sphere. When the point charge reaches the surface of the sphere, yes, its speed is, you have to find the speed. We can neglect the gravitational forces, okay. So one is positive charge and the other is negative charge. So when you release due to the Coulombic attraction, it will move towards the sphere. So at the surface you are asked to find the speed. So if I consider this as position 1 and if I consider this as position 2, then kinetic energy at 1, okay, plus potential energy at 1 should be equal to kinetic energy at 2 plus potential energy at 2, according to conservation of energy. What about kinetic energy at 1? 0. What is the potential energy at 1? That is K, or K I can write, okay, they have substituted for K. So 1 by 4 pi epsilon naught capital Q small q, okay, divided by the distance is 3r is equal to half mv square. Now what will be the potential energy at the surface? The potential at the surface can be written as minus qq by 4 pi epsilon naught and the distance is r. Okay, now solve it. You will get v is equal to root of qq divided by 3 pi epsilon naught mr. Okay, so it's a normal problem which usually they use it to ask, right? Okay, so it's question number 25 is easy only. Option 4 is the right answer. Now coming to question number 26. A car travel on a circular race track of radius 50 meter which is banked at an angle theta. If the car travel at a speed 10 meter per second, then wear and tear on its tire is minimum, taking acceleration due to gravity to be 10 meter per second square, the value of theta. See, it is easy to find the value of theta. First of all, it's a banked road, but no friction is involved, so it is v square by rg. Now just give a substitution. 10 into 10 by, what is r? 50, and what is g? 10. So what do you get? What do you get theta? Theta is equal to tan inverse 1 by 5. Yes, it's option 2. So question number 26 is option 2. Simple question. Now coming to question number 27. Okay. A frictionless circular wire of unit radius is fixed on the horizontal plane. 2 point particles of unit mass start moving simultaneously from point A, theta is equal to pi by 2, with identical uniform angular speed in opposite direction and meet at point B, theta is equal to minus pi by 2. During this time, which of the following figure schematically represent the magnitude of total linear momentum P of the system as a function of theta? So that is the question. Okay. See, looking into this question now, this is a situation. Okay, I'll give you a very logical explanation for this. Okay, rather than solving the complete maths, it's simple to look at it logically. Here I can tell this is A and this is B. Now two particles start from here. Another particle, I use another color, something dark. Okay, two particle. This particle will move this way and this particle will move this way. So from here you got what is pi by 2, right? This is actually theta is equal to pi by 2. Minus pi by 2 means this point. This will be minus pi by 2, that is clockwise, means they are going to come to this point. Okay, this particle will move and this particle will come to here. This particle will move like this and it will come here. Okay, then you are asked to find the graph for the total momentum of the system. Okay, now let's see. See, initially when they start, it have a tangential velocity v like this, or mv momentum will be like this. This will have mv momentum this way. Right or wrong? Yes or no? So at pi by 2, I can tell P total is actually 0. Okay, now let's assume this point. If you take this point, then I can tell mv, this mv will be like this and this mv will be like this. Again they are opposite direction equal, so at minus pi by 2 also I can tell P total is equal to 0. Now let's consider two other points. This one, this will be mv. Now this point, this will be mv. So what is this angle? 0 degree. Yes, at 0 degree I can tell. Okay, then for one it is 0, for the other it is pi by 2, pi 180 degree. Okay, this particle it is 0 degree, for this particle it is 180 degree. Okay, no problem. You can find the P total. That will be like 2 mv, which means at pi by 2 and at minus pi by 2 you need 0, whereas at this point momentum will be like maximum, it is going to have 2 mv. Now which graph support this one? This doesn't support, this one. Pi by 2 maximum momentum is there, so not possible. What about this one? At pi by 2 0, at minus pi by 2 0, and here which is 0, momentum is maximum. So this will be option 4. Okay, this will be option 4. So just a simple logical way of answering this question. Okay, nothing complicated. So this is option 4. Now coming to question number 28. See, there are 3 identical p-n junction diode, D1, D2 and D3 are connected across a battery as shown in the figure. If the width of the depletion region of D1, D2 and D3 are W1, for this one it is W1, for this one it is W2, and this is W3 respectively, then the correct option is, you are asked to find the correct option. Okay, before going to option, let's understand this better. This is not biased. Why not biased? Because no switch. Okay, this is not connected. Okay, so that is open there. So for this one, no biasing. Now what about this one? This is the positive terminal and this is the negative terminal. Positive terminal is connected to P and negative terminal is connected to N. So this is forward biased. I can tell this is forward biased. And what about this diode? Yes, clearly this is this way, which means this is reverse biased. So this is reverse biased. This is reverse biased. You know, reverse biased depletion width will increase, forward biased depletion width will decrease. So I can tell W3 should be greater than W2 should be greater than W1 because W1 forward bias, so depletion width should decrease, and W3 is reverse bias, depletion width should increase, which is the option here, option 4. Very simple. Hope you understood this question. Question number 28. Okay, now let's move on to next question. Yes, it's a question from bioptics. The lens combination as shown in the figure consists of two lenses L1 and L2 of focal length 10 cm and minus 10 cm respectively. The position of the image formed. So that is the question. You are asked to find the position of the image. See, there are two lenses. Okay, first of all, let's understand this process. There are two lenses. One is lens L1 and the other is lens N2. Now for L1, this is our object, so it will produce one image. Yes, somewhere here it will produce one image. Let's call it as I1. Now this I1 should act as the object for L2, then only you will get the final image. Hope you understood this. So let's do it one by one. First of all, for convex lens, I can apply the formula 1 by f is equal to 1 by v minus 1 by u. So 1 by 10 is equal to 1 by v, minus minus will become plus, applying sign convention. So 1 by v is equal to 1 by 10 minus 1 by 30, so that v is equal to 15 centimeters. Okay, now what is the problem here? Already there is a distance of 3 centimeter. You are getting 15 centimeter. From here 15 centimeter means balance this should be 12 centimeter. Hope you understood this. Okay, so I can tell like this will be 12 centimeter. Now again we have to apply the formula for concave lens. So for concave lens again 1 by f is equal to 1 by v minus 1 by u. If I apply minus 1 by 10 is equal to 1 by v minus 1 by 12. Why? Because I am taking incident direction positive, so this should be 12. Okay, concave lens focal length is negative, so if I apply 1 by v is equal to 1 by 12 minus 1 by 10, what if I solve it? V is equal to minus 60. What do you mean by minus 60? Minus 60 means left of concave lens. So what is the right option? 60 centimeter to the left of the concave lens will be your final image. Okay, so it's a normal type of question which you can see in every books, right? Yes. Now let's come to question number 30. Okay, let's come to question number 30. There is a solid sphere A of a radius capital R. Okay, already figure is here, so just I'll mark. This is capital R whose mass is capital M. Now it's at a point is attached at a point to a smaller solid sphere B of radius small r, okay, and mass is small m. Fine. Assume that the line joining their centers lie along the horizontal. The moment of inertia of the system calculated about the vertical axis passing through the center of A is Ia, and that calculated about a vertical axis passing through the center B is Ib. The difference Ia minus Ib. I need Ia minus Ib. So first of all, what will be Ia? See, Ia, when you are finding Ia, right, you have to be very careful. See, I'll come to this. Okay, one I will explain in deep, so other you can understand easily. See, if it is a normal solid sphere, this will be like 2 by 5 mr square. Now, in addition to it, there is another small solid sphere here whose mass is small m and this distance is small r, so this distance is capital R. Okay, so about this axis I can tell it is 2 by 5 m small r square, but about this axis if I need, I will have to apply parallel axis theorem. So for parallel axis theorem it is m into r plus r square, isn't it? Mass into distance square. Okay, so the add of this should be also there. Okay, so we can tell this will be like 2 by 5 small m r square plus, to apply parallel axis theorem, that will be mass into distance square, that is r plus r square. Okay, now what about Ib? Similarly, you can find Ib 2 by 5 m small r square plus 2 by 5 capital M r square plus capital M into r plus r square. Now you are asked to find Ia minus Ib. What if I do Ia minus Ib? What I am going to get? M minus capital M into r plus small r the square. So which is the right option? Option 3. So from question number 16 to question number 30, every question is not for numerical. Some question are logically you can answer, and one question is just theoretical. Okay, so hope you understood. Thank you.
Hi students, I hope you have written the RE NEET 2026 examination well. So in this video, let us discuss the solutions of the question number 31 to 45. Let us see question number 31, what they are saying to us. Consider that an electron is revolving in an excited state of hydrogen atom with the velocity v is equals to square root of 25.6 into 10 to the power of 5 meter per second. Okay, they're saying the radius of the orbit is equals to x into 10 to the power of minus 9 meter. The value of x is equals to. So how can we solve this question? For that, we have to consider that, see here, velocity v is equals to 2.26 into 10 to the power of 6 into z by n meter per second. Since for hydrogen z will become equals to 1, therefore let us say this is equation 1 and this is equation 2, correct? Therefore we can say velocity is equals to, that is root of 25.6 into 10 to the power of 5 is equals to 22.6 into 10 to the power of 5 into 1 by n. If we square it on both sides and simplify, you will get n value or n square value will become equals to 19.95 something you will get, or approximately you can take it as a 20. And we also know that Rn is equals to R naught into n square, correct? Therefore you can say 0.53 into approximately 20, so into 10 to the power of minus 10. So whenever we do simplification, you will get it as 10.57 into 10 to the power of minus 9 minus it is minus 10, but there are writing in terms of power minus 9, so we can write as 1.05 into 10 to the power of minus 9 meter. So comparing the radius Rn is equals to x into 10 power minus 9 with 1.05 into 10 power minus 9, we get x is equals to 1. That is, hence we can select option 1 as a right answer. I hope it is clear to you. See the next question, what they are saying to us. The mean free path of the molecules in an ideal gas is half of that of another ideal gas, that is lambda b by 2. The diameter of the spherical molecules of gas A, diameter of the spherical molecules of gas A is twice the diameter of the molecules of gas B. If number density of gas A is Na and Nb, they are asking what is the relation between Na and Nb. So we know that mean free path lambda is equals to 1 by root 2 pi Nd square. So whenever we do simplification or whenever observe this equation, we can say clearly lambda is inversely proportional to n into d square, or we want to know n is inversely proportional to 1 by lambda into d square. Therefore, take the ratio Na by Nb can be written as lambda b by lambda a into db square divided by da square. Substituting all the values and simplifying, you will get 2 by 4, which is equals to 1 by 2. Therefore, finally we can write Na will become equals to 1 by 2 times Nb. Hence, we can select option 1 as a right answer. Option 1 is right answer. I hope it is clear to you. See the next question. This is question number 33. What they are saying to us. A cylindrical cork of uniform density floats in a liquid of density ρ1. If the cork is depressed slightly and released, it oscillates harmonically with the time period T. If the same cork floats in another liquid of density ρ2, then the similar oscillation has time period 2t. The value of ρ2 by ρ1 is. So whenever we release a cork by compressing or by depressing a small distance x and released, it executes the simple harmonic motion. And for that, we know the time period is equals to 2 pi into root of m divided by a into rho into g. Here A is the area of cross section, rho is the density, and g is the acceleration due to gravity. So from this we can say time period is inversely proportional to square root of rho. Or we can say that rho is inversely proportional to 1t square. So using this proportionality relation, you can write ρ2 divided by ρ1 will become equals to t1 by t2 whole square. What they are saying, t1 is equals to t and t2 is equals to 2t. Therefore, substituting ρ2 by ρ1 will become equals to, so whenever we do simplification here, how much you'll get t divided by 2t whole square, and if you do simplification you'll get 1 by 2 whole square, which is nothing but 1 by 4. Hence we can select option 1 as a right answer. Got it? So move on to the next one. Question number 34. For sound waves, if the number of notes for the fifth harmonic of an open-ended pipe is n, and that for ninth harmonic of the same pipe with one of its ends closed is m, the ratio n by m is okay. So see here, in case of open pipe, we have to understand fifth harmonic corresponds to fifth frequency. So therefore we can say n will become equals to 5. N is equals to 5. Okay, now let's see. That means in one mode there will be one node and two antinodes in case of open pipe. That is, in case of closed pipe, In fundamental frequency or fundamental mode of vibration, there will be one node and one anti-node. Okay, therefore, in closed pipe, they have given ninth harmonic. Ninth harmonic. Ninth harmonic corresponds to the fifth mode of vibration. Fifth mode of vibration. Okay, so in fifth mode of vibration, the number of nodes will be equals to 5. Number of nodes will become equals to 5. Therefore, when you take the ratio n by 1, it is equal n by m, sorry, 5 by 5, it is equals to 1 by 1. Hence, we can select option 4 as the right answer. See the next question, what they are saying. I hope everyone done this question. Consider the following nuclear reaction: uranium-238 giving rise to thorium-234 plus helium nuclei. The masses of uranium, thorium, helium nucleus, everything they have given, and they are asking what is the Q value in kilo electron volts. We have to make sure about this unit clearly. We know that the Q value will become equals to mass of the reactants minus mass of the products into 931.5 million electron volt. So what is the mass of the reactants? Uranium 238, right? And how much they have given mass of the reactant? 238.050 minus of mass of the product, that is 234.043 plus 4.003. If we add, you will get 238.046, you will get it into 931.5 million electron volt. If we calculate this, you will get 0.004 into 931.5 million electron volt, and if you multiply this value, you will get 3.726 million electron volt, and you want to express this in kilo electron volts. Therefore, the Q value can be written as 3726 kilo electron volt. Hence, we can select option 2 as the right answer. Option 2 is the right answer. So, see the next question, what they are saying to us. Which of the following measurements require index correction? Okay, so read the options here. Measurement of speed of sound using resonance tube involves end correction. Okay, measurement of resistance of a wire using meter bridge also uses end correction. And measurement of gravitational acceleration using simple pendulum can be done by normal scale or normal measurement. So no need of any corrections here. Measurement of focal length of the lenses using optical bench require index correction. So therefore, we can go with option 4 as the right answer. Students, got it here? So move on to the question number 37. What they are saying to us. In a solar system, the time period of the revolution of a planet tracing a circular orbit of radius capital R is proportional to. See here, from Kepler's laws, third law, we know that T square is proportional to R cube. Therefore, T will be proportional to R to the power of 3 by 2. Hence, we can go with option 3 as the right answer. Option 3 is the right answer. See the next one, question number 38. What they are saying to us. Consider that sigma s, kb and small b represent Stephen Boltzmann's constant. Boltzmann's constant and Wien's displacement law constant respectively. The dimension of sigma s kb power minus 1 into small b is, they are saying. So for that, we have to know that sigma s will have the unit joule per second per meter square per Kelvin power 4, and Boltzmann's constant will have the unit joule per Kelvin, and Wien's displacement law constant will have the unit meter Kelvin. Now consider the given quantity here. What is the given quantity here? Sigma s into kb into small b will become equals to, just do simplification by substitution here. Only unit only you can do, no need to go for exact dimensions also here. kb power minus 1 right here, kb power minus 1. So by substituting, you'll get joule to the power of minus 1 and k to the power of plus 1 into meter Kelvin. So if you do simplification, joule, everything will get cancelled, leaving m to the power of minus 1, s to the power of minus 1 and k to the power of minus 2. And if we write in dimensional formula, L power minus 1, T power minus 1 and K to the power of minus 2. So this is the value of the dimensional formula for the given quantity. Sigma is Kb power minus 1 to small b. Hence we can go with the option 2 as a right answer. Option 2 is a right answer. So similarly, move on to the question number 39. What they are saying to us, observe this. A ray of light with wavelength lambda is incident on three different photoelectric cells, namely 1, 2 and 3. The threshold wavelength of these photo cells are lambda 1, lambda 2 and lambda 3 respectively, and the magnitude of stopping potentials of these cells are V1, V2 and V3 respectively. The relation between lambda and threshold wavelength, lambda 1 less than lambda, lambda 2 greater than lambda, lambda 3 far greater than lambda. The correct option between the stopping potentials they are asking us to calculate or to find. So let us see case 1. Case 1, what can I say case 1 here? Lambda 1 is less than lambda. That means you can say the incident wavelength is greater than the threshold wavelength. So there will be no photoelectric emission, which implies the stopping potential will become equals to 0. Got it? And whenever you go with the second case, what they're saying, lambda 2 is greater than lambda. Okay, that means there is a photoelectric emission. So from this we can say E into V2 is equals to Hc into 1 by lambda minus 1 by lambda 2. And if you do simplification, you can say V2 becomes equals to Hc by E into 1 by lambda minus 1 by lambda 2. And similarly, case 3. What is the case 3 here? Lambda 3 is far greater than lambda. So what is the thing similar to the above thing? We can write V3 will become equals to Hc by E into 1 by lambda minus 1 by lambda 3 we can write. Let us keep that value as it is. And since lambda 3 is greater than lambda 2, right now lambda 3 is far greater than lambda. Lambda 3 is greater than lambda 2. Lambda 2, what we can say here, we can say 1 by lambda 3 is less than 1 by lambda 2. So multiply by minus 1 by lambda 3 will become greater than minus 1 by lambda 2. So by adding, so which implies we can write 1 by lambda minus 1 by lambda 3 will become greater than 1 by lambda minus 1 by lambda 2. So therefore, what is 1 by lambda minus 1 by lambda 3 gives me here? It is V3, right? It is a V3. Hence we can select V3 is greater than V2. V3 is greater than V2. Hence we can go with option 2 as the right answer. Option 2 is the right answer. I hope it is clear to you. Move on to the question number 40. What they are saying to us. One main scale division of a vernier calipers is equals to, one main scale division value is equals to 1 millimeter, and number of VSDs vernier scale divisions is given to be equals to 10. Clear? And therefore from this we can calculate what is the least count. Least count is equals to 1 mm divided by 10. Therefore, least count will become 0.1 millimeter, or we can write 0.01 centimeter. Understood? Not only that, what they are saying, the vernier scale shifts to the left of 0 of the main scale in such a way that fourth vernier division coincides with the division of the main scale. That means they have given coinciding vernier division is also equals to 4. Not only that, and see here it measures 1 centimeter, which implies main scale reading is given as 1 centimeter. Now they're asking what is the actual length of the reading. So true reading is equals to, otherwise the total reading is equals to MSR plus CVD into least count we can write. Just substitute value here 1 plus what is CVD 4 into 0.01. It becomes equals to 1.04 centimeter. Hence we can select option 1 as a right answer. Understood, students? So move on to the next question. What they are saying to us. A point charge capital Q is placed inside a cavity within a solid isolated conducting sphere. Consider the points A, B, and C. A is inside this cavity, B and C are equidistant from the center of the outer sphere, outer solid sphere. The correct option is, they are saying, they are saying. So how can we simplify this? They're asking about what is a field, See here, whenever you check it, the charge capital Q is placed inside the cavity, right? So therefore, because of induction, we can say there will be minus Q and there will be plus Q outside. And since we can say the point A is inside the cavity at a distance from charge capital Q, therefore we can say field at the point A is not equals to 0. Not only that, see here, the distance RA is equals to RB. We can say that electric field at the point B will become equals to, okay, sorry, this is not RA, it is RC. It is equals to, it is EC. Hence we can select what is the option? We can say here option 3. Option 3 is the right answer. And move on to the next question, that is 42. In Geiger-Marsden experiment, the number of scattered alpha particles n theta is plotted as a function of scattering angle theta. Which of the following options represents the correct plot? Is one of the standard NCERT diagram right now here. So n of theta is inversely proportional to 1 by sine to the power of 4 theta by 2. That means as the theta increases, number of alpha particles scattered will decrease. Hence we can select option 4 as the right answer. Option 4 is the right answer. See the 43 question here. 1 mole of an ideal monatomic gas undergoes a cyclic process as shown in figure. Since it is a cyclic process, what can you say here? Delta U will become equals to 0, So therefore, calculate the amount of work done. Amount of work done is equals to area under PV graph, okay. So therefore, calculate the work done. Work done is equals to, it is a rectangle, right? It is a rectangle. Therefore, what is the length here? 5 minus 2 meter cube into breadth is equals to 300 minus 100. It becomes equals to 3 into 200, nothing but 600 joules. Therefore, using first law of thermodynamics, we can write the heat supplied is equals to delta U plus W. You will get the answer as 600 joules. Hence, we can select option 4 as the right answer. I hope it is clear to you. So move on to the question number 44. What they are saying to us. Two infinitely long parallel conducting wires A and B carry the currents I and 2I respectively in the same direction. The wire A has uniform mass per unit length lambda. and lies on an insulated floor. Insulated floor. Let us say the wire. What is the wire here? The wire A is lying on insulated floor, which carries the current. Let us say I. The wire B is kept fixed at a height h, which carries the current 2I, let us say, and the distance between these two wires is equals to h. The minimum height h, so that the wire A does not rise from the floor. So at what condition the wire A will not rise from the floor? So whenever the magnetic force between these two conductors balances the gravitational force. Therefore, what is the magnetic force per unit length here? Unit length, we know that it is equals to mu naught by 4 pi into I1 I2 divided by D. By substituting the value, you will get mu naught by 4 pi into I into 2I divided by D is h. So simplifying, we will get mu naught into 2 1 2 will get cancelled, mu naught into I square divided by 2 pi h. Let us say equation 1. And what is the gravitational force here? M into G. But they have given in terms of lambda, right? If G by L is equals to M by L into G, which is nothing but lambda G. Let us say equation 2. So for equilibrium condition, we can write mu naught I square divided by 2 pi h is equals to lambda into G. So if you do simplification, lambda will become equals to mu naught I square. H must be equals to lambda is equals to mu naught I square divided by 2 pi h into G. So cross multiplying this, I will get h is equals to mu naught I square divided by what can you say here? So please think about this here. You get 2 everything will get cancelled, right? Mu naught by 4 pi into, here I want to change the formula 2 times. It is also 2. So everything will get cancelled. There will not be 4. 4 will not be there here. There will not be 2 here. Therefore, finally, h will become equals to mu naught I square divided by pi lambda. H is equals to mu naught I square divided by pi lambda into G. I hope it is clear to you, students. So move on to the next question, what they are saying to us. Question number 45. Consider spring mass simple harmonic oscillator in one dimension. The mass of the particle is m kg and the spring constant is k Newton per meter at a given instant. The extension of the spring is x meter and the speed of the particle is v meter per second. On the xv plane, if the graph of v as a function of x is a circle, then the correct option is, that means we have to find the relation between k and m. What they are given here, observe this. On xv plane, the graph of v versus x is a circle. So see here, whenever you plot by taking x and v, then it will get a circle. And for a circle, we can write v square by a square plus x square by a square must be equals to 1. Let us call this as equation 1. Now let us see, whenever the spring mass system is oscillating, it will possess two types of energies, and the total energy will become equals to the kinetic energy of the block plus the potential energy of the spring. Therefore, we have to write this equation in the form of equation 1. Okay, therefore, we can say, observe this, half mv square divided by E plus half kx square divided by E must be equals to 1. So rewriting this, we'll get v square divided by 2E by m, okay, plus x square divided by 2e by k is equals to 1. So in order to satisfy the circle equation, we can say 2e by m must be equals to 2e by k. 2e by k. So simplifying, we can write k will become equals to m. Hence we can select option 3 as a right answer. Students, I hope it is clear to you. So with this, the questions have been completed. We'll meet you in the next session. Thank you very much.
Hope you all have done your chemistry RE NEET 2026 very well. Comparing the previous question paper, this seems to be a little bit to the next level. Okay, right. Anyway, the question paper seems to be having 6 questions of choose the best answer or choose which is the right option. Like that, 6 questions are there. 4 questions are there with statement 1 and 2. Statement 1 and 2, 4 questions are there. And 3 questions are there in assertion and reason type. 19 direct questions are there and 13 questions are there which you have to work out and do other questions. So when coming for the direct questions, there are 19 questions. In total, we have 45 questions. Comparatively, this seems to be an average question paper only. Comparing the previous one, it seems to be a little bit to the next level, but it is an average one. Okay, let us start discussing the questions. 46. Consider the following reaction and choose the correct option. So this is a very mild oxidizing agent, you know that. And acidic medium, it is having a catalytic poison. So your answer is aldehyde. Benzaldehyde is your product. Now coming for the options. First one, it is obtained by the hydrogenation of benzoyl chloride with palladium and barium sulfate. Yeah, it is correct because it is Rosenmund reduction. So this is the correct equation, correct answer. And this is not a carboxylic acid because carboxylic acid alone will give effervescence, and this cannot be prepared by acylation, and also this is not phenol to give precipitate with bromine water. So the answer for the first question is option 1. 46th question is option 1. 47th question. The formula for tetraamine, that means 4 ammonia is acting as ligand, aqua 1 water molecule, chlorido and cobalt 3 plus inside means there should be 2 chlorine ions outside. So the answer is option 1 for the 47th question. 48th one, holmium 3 plus. This seems to be 4 of 10 configuration. Neodymium 3 plus. This is 4 of 3 configuration. Cerium 3 plus. This is 4 of 1 configuration. And terbium 3 plus. This is 4 of 8 configuration. So when we compare all of them, this is the reliable answer. Why? Because F orbitals are split up into 7 orbitals. 1, 2, 3, 4, 5, 6, 7. Yeah. The first electron here, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. Now you will be having 4 unpaired electrons in the case of option 1. Right. Question number 49. Right. You know Arrhenius equation. So ln K is equal to ln A minus EA by RT. Simply RT. So when you are going with ln K in y-axis and 1 by T in x-axis, the intercept is ln A. Intercept is nothing but given in the diagram it is 6. Ln A is 6. And we have to go for the slope which is nothing but minus EA by R. Minus EA by R. So substituting the values. Ln K is referred as E square in the question. Equal to ln A is nothing but 6. Minus EA is referred as 6640 joules. Divided by R is 8.3 into T. So when we solve, this is nothing but 2 ln E. Ln and E gets cancelled. It is equal to 6 minus 800 by T. So the final answer is 200 Kelvin. You solve this very simply. You will get 200 Kelvin as your answer. Question number 50. The green paramagnetic species which is obtained by heating KMnO4 is nothing but at 500 Kelvin. It is K2MnO4, which is nothing but potassium manganate. The answer is option 2. Right. Question number 51. When coming for the 51st question, look at the question very carefully. What is given here? First one is trans to butene. You know the short trick TAM. If you go for a trans compound and if it is an anti-addition, yes sir, this addition of bromine is an anti-addition. The product is a meso product. The product is a meso product. How you know this is a meso compound? Look at the first carbon. This is having bromine at the top. And if I rotate the second carbon by 180 degree, the bromine here will come exactly to the back of this bromine, to the exact back of this bromine. So if it goes to the exact back now, it will be like bromine with methyl and hydrogen. This is a meso structure which is given here. And cis compound, we have mentioned it as a short trick called CAR. Cis compound anti-addition racemic mixture is your product. Here cis compound, but the addition is what addition? Syn addition. So cis compound syn addition meso is your product. This is not meso because the two OH groups are adjacent to each other. They will be having a strong intermolecular hydrogen bonding where it is not going to be a meso structure. So here, what is the correct answer for the 51st question? Statement 1 is given meso, which is correct, and statement 2, this is not meso, which is incorrect. So the answer for the question is option 4. Option 4. 52. One of the products formed whenever you see a Grignard reagent is treated with a primary amine or a secondary amine or ammonia. This R minus combines with one of the hydrogens and it will become alkane. So one of the product formed is cyclohexane. 53rd question. Heating NaCl with concentrated sulfuric acid and MnO2. MnO2 is an oxidizing agent in this reaction which oxidizes NaCl. When treated with sulfuric acid in acidic medium, NaCl is converted into chlorine, sodium bisulfate, MnSO4 along with water. This is the reaction part. The same in the case of iodide also. If you use NaI, the product will be I2. All the remaining things are same. Look at the equation carefully. The manganese from +4 charge, it is going to +2 charge. So it is getting reduced. This statement is true statement. Oxidation is wrong statement. So statement 1 is wrong and 2 is correct. The answer is option 1. Coming for the 54th question. Among the following options, the correct trend in electron gain enthalpy. This is a very, very direct question. I think you all are very clear in this concept. The answer is option 4. Coming for the 55th question. The first complex which is given is MAA thrice 3 minus this type. Right? And the all cis form is chiral. It is optically active. It is having optical isomers. It is chiral. When you go for this trans compound, there is a plane of symmetry. And this is achiral. So this is true and this is not true. So the answer for this question is option 4. Okay? Thank you.
Question number 56. The correct statement about peptides and proteins is: first option, in alpha helix, the polypeptide chain is twisted into left-handed screw. Generally, in alpha helix, polypeptide chain is twisted into the right-handed screw, not left-handed. It is a right-handed screw. So the first statement is wrong. You can go to the second statement. Tertiary structure of proteins has 2 or more polypeptide subunits. Generally, tertiary structures are 3-dimensional structures with only single polypeptide, not 2 or more. So second statement is also wrong. Can go to the third one. Only the proteins having quaternary structure are biologically active. So again it is not necessary to be a quaternary structure. Even primary, secondary and tertiary structures of proteins also can be biologically active. So option 3, the statement 3 also wrong. Fourth one, in beta pleated structures, peptide chains are held together by intermolecular hydrogen bonds. That is true. We know that the two polypeptide chains are held together, okay, by the intermolecular hydrogen bonds. Okay, option 4 is correct for this. Can see question number 57. Given below are two statements. Oxidation of para-nitrotoluene with acidic KMnO4 gives an acid which is stronger than benzoic acid. Yes, that statement is true because you can see para-nitrotoluene CH3 and at para position nitro group on strong oxidation it is converting into the para nitrobenzoic acid. Since the nitro group is a minus M group, withdrawing group, that increases the acidic character of the acid, and it is more acidic than benzoic acid. That statement is true. Whereas the next one, reduction of para nitrotoluene with tin by HCl followed by neutralization gives an amine that is more basic than aniline. Yes, even that statement also true, because para nitrotoluene we are doing reduction tin by HCl. So on reduction it gives 4-methyl aniline. Okay, the methyl group is acting as a plus I group. Okay, so that it is more basic than aniline, simple aniline. So here in this question both the statements are correct. Both statement 1 and statement 2 are correct. Option 2 is correct one. We'll move to the next one. Can see question number 58. Identify the reactions which gives aniline as a major product. Okay, you can see the first one, cyanide on reducing with lithium aluminum hydride. So it will form benzyl amine, not aniline. So the first one is wrong. Second one, you can see the reagent KOH and Br2, that is a Hoffman bromide degradation reaction. We know that in that reaction amides are converting into the amines. Okay, here the C double bond will be eliminated, degraded, so then the product will be aniline. So this will give aniline, and but the question they are asking multiple correct answers. So we can see the next one also. C, in the option C, okay, NaBH4 given, that is a mild reducing agent, so which cannot reduce the NO2 group, so that this will not give aniline. And last one, it is an amide that they are doing acidic hydrolysis. Amides on acidic hydrolysis gives the amines. So here hydrogen, here OH, if you can take the product NH2 plus CH3COOH. So here this is also giving the aniline. So in this question there are two reactions giving aniline, that is B and D. We can check the option 3 have the both the statements, that is B and D. So here option 3 is correct. We'll move to the next question, that is question number 59. Here it is very easy. 2 moles N is equal to 2 of ideal gas undergoes free expansion. Very important line, this is free expansion. In free expansion we know that Q is equal to 0, W is equal to 0, delta U is equal to 0. Okay, and from 10 liters to 100 liters, expanding from the 10 liters to 100 liters, V1 is equal to 10 liters, V2 is equal to 100 liters at 300 Kelvin. The values of the change in entropy of system and change in entropy of surroundings are. Change in entropy of system and entropy of surroundings are. We know the formula. Change in entropy of system equal to 2.303 NR log V2 by V1. So 2.303 N value is 2 given. So R value we need not to apply, because in the options also R is there. So we need not to substitute the values of R. Okay, then directly take it as R only. What about the N? N value is given as 2, because in the initially they said that 2 moles of ideal gas into 2, okay, into log V2 100 by V1 10. If we cancel this one, log 10 value we know log 10 value is 1. If you multiply that one 2.303 into 2, it is 4.606 R. Okay, change in entropy of the system will be 4.606 R. Now we have to see that change in entropy of the surroundings, that is equal to minus q by t. The formula is minus q by t. We already seen that it is 0. Okay, so then change in entropy of surroundings will be 0. Change in entropy of system is 4.606 R, surroundings is 0. That option 1 will be correct one for this given question. Okay, we'll move to the next one. The compound that cannot be obtained from aldol condensation reaction shown below. It is very easy to understand. They are given two different aldehydes in which one have alpha hydrogen, the other will not have alpha hydrogen. Okay, so definitely this benzaldehyde can be acts as only as electrophile. It cannot act as a nucleophile. It do not have the alpha hydrogens. So it has alpha hydrogens. It will take and attack here. So first option is possible. Okay, coming to the second option, and here you can check that as the product of aldol condensation we can expect the alpha beta unsaturated carbonyl compounds. You can see here alpha beta gamma, so we are getting here beta and gamma. So this is wrong, it is not possible. Okay, so in this question they are asking cannot be obtained. Option 2 cannot be obtained. Okay, option 3 also possible. This is E and Z. Okay, these two are isomers, that is also possible, and 4 also possible with the same molecule. It is possible. We can move to the next question. That is question number 61. The complex which has facial and meridional isomers. We know that Ma3B3 type complexes will show the facial and meridional. Okay, so first one you can see MAA twice and B2, it will not show facial and meridional. Here you can see A3B3, simple direct question. Okay, Ma3B3 type complexes only can show the facial and meridional isomers. So for the 61st question, option 2 is correct. We can move to the next one. Question number 62. Okay, it is very basic question actually, maybe unexpected one. Okay, you can easily answer this anyhow. The three numbers, okay, 17.0145 and 21.0235 were rounded off to the three figures after the decimal point. Okay, so you can see here 17.0145, we need only three figures. The last one is 5. Okay, the preceding number is 4. It is even number, so that it will not change. So we can write it as like 17.014. Okay, the next one is 21.0235. Here also the last one is 5 only, but the preceding one is a odd number. So when odd number is there, it is increased by one digit. Okay, increased by one digit, so that 21.024. You can check the options. It is match with which one? To match with 4. 17.014, 21.024, option 4. Fine. We are going to the next one, that is question number 63. Question number 63. Check it out, it is very easy. Okay, so the combustion of the butane gas, N-butane they given. Okay, fine. You can see that first we can balance this equation, C4H10. Okay, that combustion means reacting with oxygen that forms carbon dioxide and water. Okay, they are asking only about carbon dioxide. Here 4 carbons are there, we can write 4 CO2 will be formed. Okay, for 1 mole of the butane we are getting 4 moles of the CO2. Okay, but in this question they are not given 1 mole, they have given 116 grams of the N-butane. So from the given mass we can find the number of moles by using a formula 116 given mass by molecular mass of butane. Can you find molecular mass of butane? C4H10. Okay, 4 into 12, 48 plus 10, 58. Okay, if you cancel that, you will get the 2 moles. For 1 mole, if you get the 4 moles of carbon dioxide, for 2 moles, you will get the 8 moles of carbon dioxide. Okay, so 8 moles of carbon dioxide weighs that number of moles into molecular mass. Molecular mass of carbon dioxide will be 44. If you multiply that, you will get the answer 352. Option 2 is correct. You can move to the next one. Question number 64. Consider the following schematic plots of orbitals wave function against the distance r from the nucleus. Okay, the question is incomplete. We can check it out. Yes, here you can see that the figure representing two radial nodes in the orbital is two radial nodes. Which figure is representing the two radial nodes? We'll check one by one. So you can see the first A1, the line is not crossing the axis. Okay, so it would have 0 nodes, 0 radial nodes. Okay, and the second one, it is crossing the axis once, only once. So one radial node possible. The option C, it is crossing the axis once and twice. It is having 2. Whereas the fourth option, you might think that it is also starting from this one only, right? But it is a typical p orbital, okay, where electron density is 0 near the nucleus for p orbital. Okay, this is not considered as a radial node, and it is a angular node. Okay, so here it is crossing only once, then it is having one node only. So C will have the 2 radial nodes. You can see the option 4C, correct. So we'll move to the last question, the next question, sorry, that is question number 65. Okay, the following carbocation is stabilized by the interaction of empty p orbital with, so this is empty p orbital. Okay, so it is very easy, and empty p orbital can be stabilized by the filled one. Okay, so empty 5 star is not possible, empty sigma not possible, and empty sigma star is not possible. You can eliminate in that way. That is one thing, you know that. And sigma star and pi star anti-bonding orbitals cannot donate the electrons. That is also one fact. Okay, and anyhow you can see that, and it is stabilized by the resonance with the benzene ring due to the pi electrons. Okay, and one side it can stabilized by the pi electrons, filled pi orbitals. Okay, the other side it is also showing the hyperconjugation of the sigma CH bond. Okay, that is a filled sigma, okay, orbital, filled sigma orbital. So this side filled sigma orbital, this side filled pi orbitals. So it is stabilized by the both. So you can choose the option 2.
Hello everyone. So we are going to discuss question number 66. So the question is a 1:3 electrolyte in an aqueous solution is. So they have given you 4 electrolytes which is in complex form, and when they are added to water, which all will give the ratio of cation and anion in 1:3. So that is a question. So let's see each and every option. The first one is CONH3 thrice NO2 thrice. So this is a neutral complex. So when it is added to water or aqueous medium, it will not undergo ionization to give cations or anions. So we are not having ratio of cation to anion. Now coming to second option, it is COCl2 NH3 4 times Cl. In this, in aqueous medium, it will dissociate to give COCl2 NH3 4 times plus Cl minus. In this, the cation to anion ratio, mole ratio will be 1:1. Now the third one is COCl NH3 5 times Cl2. When this is added to aqueous media, it will dissociate to give the cationic part, which is COCl NH3 5 times 2 plus 2Cl minus. If you check the mole ratio of cation and anion, it will be 1:2. Now the last one is CONH3 6 times Cl3, which is added to aqueous medium will give you CONH3 6 times 3 plus 3Cl minus. When you check the mole ratio of cation and anion, it will be 1:3, which is asked in the question. So the answer will be option 4. Now, question number 67. The standard electrode potential for the half cell reaction Fe3 plus electron gives Fe2 plus at 298 Kelvin is. They have given you the reduction potential of ferric ion as well as reduction potential of ferrous ion. So let's see the reduction potential or reduction reaction of ferric ion, that is Fe3 plus 3 electron will give you Fe. The potential of this reaction is minus 0.04 volt. Now the next reaction is reduction of ferrous ion, that is Fe2 plus 2 electron will give you Fe. The potential is minus 0.44 volt. Now from these two reactions we have to frame this final reduction reaction. For that, we can take the first reaction as it is, that is Fe3 plus 3 electron will give you Fe. The potential of this reduction is minus 0.04 volt. Now, we need Fe2 plus in the product side. For that, we can reverse the second reaction. When you reverse the second reaction, it will be Fe gives Fe2 plus 2 electron. Now it became the oxidation. Oxidation potential of this reaction will be 0.44 volt plus 0.44 volt. Now when you add these two reactions, you will be getting the required reaction, that is Fe3 plus 1 electron gives Fe2 plus. But we cannot add this reduction potential or electrode potential value. Why? Because electrode potential is an intensive property. It is an intensive property. So for that we will take extensive property, that is delta G. Delta G is an extensive property which is additive. So we can see that if I'm taking this as the first reaction, this is the second reaction and this is the third reaction, we can say that delta G1 of the first reaction plus delta G2 of the second reaction will give delta G3. And delta G is equal to minus NF E naught, or potential is the relation between electrode potential and Gibbs free energy. So when you take this, when you add delta G1, delta G2 to get delta G3, we will be getting the final equation, that is N1 E1 plus N2 E2 will give N3 E3. N is the number of electron transferred during the reduction or oxidation. So the first reaction N1 will be 3 into its potential is minus 0.04 volt plus N2 is the number of electron in the second reaction, that is 2 into its potential is 0.44, that is equal to N3 is the number of electron transferred in the final reaction, that is 1 into E naught or electrode potential. So E naught will be equal to minus 0.12 plus 0.88. So you'll be getting the answer 0.72 volt plus 0.72 volt. So the answer for this reaction will be option 3. Next is question number 68. In potash alum, the ratio of K plus and SO4 2 minus ion is. So the formula of potash alum is a double salt. Its formula is K2SO4 dot Al2SO4 thrice 24H2. So in this, the ratio of mole ratio of K plus ion and sulfate ion is, you can see that there is 2 moles of K plus ion and 4 moles of sulfate ion. So when you simplify this ratio, it will be 1:2. So the answer will be option 2. Next is question number 69. Consider the following statements about the solutions formed by mixing two liquids. First one is an ideal solution thus formed obeys Raoult's law throughout the composition range. So we know that if I'm taking two liquids A and B, if I mix this to get ideal solution, then this ideal solution will obey Raoult's law in all throughout its composition. So we can say that the first statement is correct. Now the next is second statement. Mixture of chloroform and acetone shows negative deviation from Raoult's law. So if I take chloroform, it is CHCl3. Next, acetone is CH3, C double bond O, CH3. Between chloroform and acetone, it can make intermolecular hydrogen bonding. So due to this intermolecular hydrogen bonding, the solute-solvent interaction will be greater than solute-solute and solvent-solvent interaction, which make this combination comes under non-ideal solution with negative deviation. Non-ideal solution with negative deviation. So the statement B is correct. Now the next is statement C. A mixture of aniline and phenol. If you take aniline, it is NH2, then phenol. These shows positive deviation from Raoult's law. Actually, aniline and phenol are similar to chloroform and acetone. Between aniline and phenol, intermolecular hydrogen bonding is possible, which again make the solution comes under non-ideal solution with negative deviation. So the statement C is incorrect. So the right option for this question is option 2. A and B only are correct. Now the next is question number 70. For a salt XY, which is a strong electrolyte, the plot of lambda n versus root C has a slope of minus 90 Siemens centimeter square, mole raised to minus 3 by 2, liter raised to 1 by 2 at 298 Kelvin. At 0.01 molar concentration of XY, the value of lambda m is 145 Siemens centimeter square per mole, and the limiting molar conductivity of Y minus ion at 298 Kelvin will be. They have also given the limiting molar conductivity of X plus ion. So we have to find limiting molar conductivity of Y minus ion. So we know that from this question, it is clear that they are actually describing about the Debye-Huckel relation. So according to Debye-Huckel relation, we know that lambda m is equal to lambda naught m minus a c, which explains or which describes the graph of molar conductivity versus root of concentration of strong electrolyte. So this is the graph. So from this, we can find limiting molar conductivity of XY, that is lambda m is equal to lambda naught m minus a root c. Lambda m they have already given, it is 145 is equal to lambda naught m minus the slope they have already given, it is minus 90, root of concentration they have already given, it is 0.01, that is 10 raised to minus 2. So it will be 145 is equal to lambda naught m minus 9. So lambda naught m will be 145 plus 9. It will be 154 Siemens centimeter square per mole. So we know that if you get limiting molar conductivity of an electrolyte, according to Kalrusch's law, limiting molar conductivity of an electrolyte will be sum of the limiting molar conductivity of all the individual ions present in that electrolyte. So from this, we can substitute in this equation. So limiting molar conductivity of XY is 154, that is equal to limiting molar conductivity of X plus is 74 plus limiting molar conductivity of Y minus. So limiting molar conductivity of Y minus will be equal to 154 minus 74, that is equal to 80 Siemens centimeter square per mole will be the answer. So it is option 2. So the answer is option 2, 80. Next, question number 71. Arrange the following compounds in increasing order of polarity. So let's check the compounds they have given. The first compound is diethyl ether, which is an ether. Second one is ethanol, which is an alcohol. Third one is acetone, which is a ketone. And the last one is acetic acid, which is a carboxylic acid. So we know that when you compare the polarity of these, an acetic acid will be or carboxylic acid will be having highest polarity because they are able to form intermolecular hydrogen bonding that even lead for dimerization of that molecule. So it can form high intermolecular hydrogen bonding. So that is why we can say that carboxylic acid will be having highest polarity. Now the next will be alcohol because in alcohols also intermolecular hydrogen bonding is possible. Then when we compare ether and ketone, in ketone due to the presence of this carbonyl bond, it is more polar than ether. So ketones are more polar than ether. So considering this order, we can see that the highest polarity will be for acetic acid, which is D. Then it will be alcohol, which is B. Then it will be ketone, acetone, which is C. And the least will be for diethyl ether, which is A. So when it matches with option 1. So option 1 is the correct answer. Next is question number 72. According to crystal field theory, the correct order of ligands with respect to their decreasing order of field strength is. So we know that spectrochemical series. According to spectrochemical series, the order of strength of ligands are in the order carbonyl greater than, cyanido greater than, nitrito greater than, ethylene diamine greater than, amino greater than, isothiocyanate greater than, aqua greater than, oxalato will be greater than, hydroxido it will be greater than, fluorido, then it will be chlorido, then thiocyanato, then sulfido, bromido, irido. This is the order of spectrochemical series based on the ligand strength. So from this order, it is clear that from the given options, carbonyl will be having the greatest field strength. Then it will be amine, then it will be aqua, and the least will be for chlorido. So this matches with the option 2. So the answer for this question will be option 2. Next is question number 73. The amino acids that gives a red blood color on treating its sodium fusion extract with sodium nitroprusside. So we know that when a sodium fusion extract is treated with sodium nitroprusside, if it gives a red or violet colored precipitate, it shows the test for sulfide. So our task is to find in which of the following amino acid the sulfur element is present. Because those amino acids, when it is converted to sodium fusion extract, on further treatment with sodium nitroprusside will give you a red blood color precipitate. So let's see. So generally, when we take the structure of amino acid, it will be having a chiral carbon having acid group, amino group, then one hydrogen will be there and one alkyl group will be there. Based on this change in alkyl group, different amino acids comes. So let's check the structure of the amino acids present in the option. The first one is serine. The structure of serine will be, you can see that as R group in serine, we will be having CH2OH. Next is leucine. In leucine, you can see that as R group, you will be having CH2, CH, CH3, CH3, which is isobutyl group as R group. Next one is threonine. In threonine, you can see that as R group, you will be having CHOH, CH3 as R group. And the last one is methionine. In methionine, the R group is you can see that the arc group will be CH2, CH2, sulfur, CH3. So in this, sulfur is present. So when methane is converted to sodium fusion extract and on further treatment with sodium nitroprusside will give you red blood precipitate. So the answer for this question is option 4, methane. Now let's move to the next question, 74. In an acidic medium, 10 ml of 0.25 molar oxalic acid is titrated with a KMnO4 solution. If the volume of KMnO4 solution required to reach the endpoint is 10 ml, the strength of KMnO4 is. Strength of KMnO4 means they are asking about the concentration, that is molarity. So we know that during titration, the number of gram equivalents of titrant and titrate will be same. That means number of gram equivalents of KMnO4 will be equal to number of gram equivalents of oxalic acid, H2C2O4. Now, how can you find number of gram equivalents? Number of gram equivalents is equal to, number of gram equivalents is equal to, in terms of molarity, we can say that molarity into volume into N factor. So we need to find N factor because molarity and volume is already given in the question. So if you take KMnO4, I am taking MnO4 minus permanganate ion. MnO4 minus in acidic medium, it will get reduced to Mn2 plus. So we know that here in MnO4 minus, it is having plus 7 oxidation state. When it is reduced to plus 2 oxidation state, 5 electrons will be accepted. The next is oxalate ion C2O4 2 minus or oxalic acid. It get oxidized in presence of KMnO4 to carbon dioxide. So when you check this C2O4 2 minus, carbon is having plus 3 oxidation state. It will give 2 carbon dioxide. Carbon will be having plus 4 oxidation state. So during this oxidation, 2 moles of electrons will be transferred. Why we have calculated this number of electron transferred? Because for a redox reaction, N factor is number of electrons transferred during redox reaction. So let's see. So we know that number of gram equivalents of KMnO4 will be equal to number of gram equivalents of oxalic acid. That means I'm taking this KMnO4 as the first one and oxalic as the second one. So we can write the equation as M1V1N1 will be equal to M2V2N2. For KMnO4, we have to find the molarity. So you can take it as M1 itself. Volume they have mentioned it is 10 ml. 10 ml into number of moles, N factor or number of moles of electron transferred is 5. That is equal to, for oxalic acid, molarity is 0.25 into volume is 10 ml into N factor, which is number of electron transferred, it is 2. So when you check this, you can see that this 10 will get cancelled. 5, it will be 0.05. 0.05 into 2, it will be 0.1 molar. So that concentration or strength of KMnO4 will be 0.1 molar, which is option 2. Got this? Now we are moving towards the next question. Question number 75. The correct statement is aluminium has 5 valence orbital. Let's check it. Aluminium. What is the valence electronic configuration of aluminium? 3s2, 3p1. So here you can see that it is having S subshell. S subshell is having 1 orbital. P subshell, we know that it is having 3 orbitals. So as a whole, it is having 4 valence orbitals. What they have given is 5, which is incorrect. 5 is incorrect. So the statement 1 is incorrect. Next statement is option 2. Boron has a maximum covalency of 4. We know that boron belongs to second period elements. The maximum valency or covalency of second period elements is restricted to 4. Why? Because they do not have vacant d orbital. Due to absence of this vacant d orbital, it cannot extend its covalency its covalency beyond 4. So we can say that statement 2 is correct, which is boron has maximum covalency of 4. The next third statement is beryllium has 3 valence orbitals. So when you take beryllium, the valence electronic configuration of beryllium is 2s2. So here this 2s2 s orbital, sorry, s subshell is having one orbital. So we can say that it is having only one valence orbital. So which is incorrect in given option. So option 3 is incorrect. And the last option they have given us, magnesium has a maximum covalency of 4. We know that magnesium belongs to the second group element. Its configuration is 3s2. Even though it is having 2 electrons in its outermost shell, we expect that magnesium can make only 2 bonds. But we can say that in certain complexes, magnesium acts as central metal and it can accept electron from about 6 ligands. So we can say that its covalency can be up to 6. It is not up to, or maximum covalency is not 4. It can be extended up to 6. So the statement 4 is also incorrect. So that's all about the question up to 75. Thank you.
Hello dear students, this session I am going to discuss about the RE NEET 2026 question paper from question number 26 to question number 90. Among the following, the compound having conjugated double bond. Conjugate to double bond means alternate to double bond. For example, if you take the option number 2, 1, 3 butadiene. 1, 2, 3, 4, 5, 6, 7. Hept. 1, 2, 3, 4, 5, 6, 7. First position double bond and third position double bond. So hept 1, 3 diene. It has alternative double bond, that's why it is called conjugated double bond. So question number 76, booklet number 70, question number 76, option 2 is correct. Now coming to the question number 77, 2A gives rise to B, it is a zero order reaction. 2A gives rise to B, it is a zero order reaction. So zero order reaction, rate of reaction proportional to molar concentration of the reactants. Then rate is equal to K into A power 0. So rate is equal to rate constant. So this is according to zero order reaction. According to rate definition what? Decrease in concentration of the reactants per unit time. Rate is equal to decrease in concentration of the reactant per unit time. So now we have the reactant A minus dA by dt and you have the stoichiometric coefficient 1 by 2. So you have to write in denominator minus 1 by 2 is equal to K into A power 0. A power 0 is nothing but 1. Now you can write the equation, rearrange the equation. dA is equal to minus 2 into dt. Now integrate on both sides. Integrate on both sides. Integrate on both sides. Then finally what is the equation? dA integration, this is A naught initial concentration, this is AT final concentration, minus K into dt. Minus K you can write here dt, initial and final. So finally you will get upper limit minus lower limit. Upper limit minus lower limit, that is equal to minus 2K minus 2K into T. So upper limit T minus 0, lower limit. So minus 2KT and here AT minus A naught. Now here they given initial concentration. Initial concentration given A naught. A naught is equal to 2 molar and then the time taken for 75% is completion. So 2 into 75 by 100, that is equal to 3 by 4, that is equal to 1 by 2, 3 by 2, that is equal to 1.5. So initial concentration given 2 molar, and we have the 75% dissociated, you have the remaining 1.5, so that is equal to minus 2 kT. Okay, initial concentration given as 2, and here you have the 1.5. Now you can rearrange with the negative sign. 2 minus 1.5 is equal to 2 kT, that is equal to 0.5 is equal to 2 kT. K value is given as 1, 2 into 1 into T, that is equal to T is equal to 0.5 by 2, that is equal to 0.75 minutes. So this is the correct option. Please check your key. 0.75 minutes is the correct option. Okay, for question number 77, option 3 is the correct option. Now coming to the point, question number 78. Question number 78, which is based on the solubility product. We have the general equation KSP is equal to x power x, y power y, s power x plus y, based on this. Now here we have the AGBR. AGBR is 1:1 salt. So AGBR KSP is equal to 1 power 1, 1 power 1, s power 1 plus 1, that is equal to s square. AGBR KSP value 5 into 10 to the power of minus 13 is equal to s square. Therefore s is equal to root over 5 into 10 to the power of minus 13. After solving this equation, you will get 7.1 into 10 to the power of minus 7 molar. So this is about AGBR salt. Second one, ZnOH twice. It is looking like a 1:2 type. KSP is equal to 1 power 1, 2 power 1, 2 power 2, s power 2 plus 1. That means 4s cube. KSP value is given for zinc hydroxide. 10 to the power of minus 15 is equal to 4s cube. Then s is equal to 10 to the power of minus 15 by 4 cube root. After solving this, you will get the value 6.3 into 10 to the power of minus 6 molar. So 10 to the power of minus 7, 10 to the power of minus 6, which is more value? Definitely 10 to the power of minus 6 is the highest value. After that, Hg2Cl2. This is very important. Hg2Cl2 mercurous chloride. It is dissociated as Hg2 plus 2Cl minus. Hg22 plus 2Cl minus. S 2S. So that is equal to, here you will get 4s cube. You will get the value 4s cube. 4s cube is equal to 1.3 into 10 to the power of minus 10. Then s cube is equal, s is equal to 1.3 by 4 10 to the power of minus 18 cube root. So finally calculation, you will get 6.9 into 10 to the power of minus 7 molar. So if you compare these two among these values, which is the highest value? 6.3 zinc hydroxide. After that 6.9 and 7.9, which is highest value? 7.9. 7.1 into 10 to the power of minus 7. So the answer is option 1, zinc hydroxide, silver bromide, Hg2Cl2, and your option is final option 1, question number 78, option 1. Now coming to the question number 79, they are asking the correct order of decreasing order of their oxidation state of underlying element of each of the molecule. The correct option is option 3. Why? Because N2O5 oxidation state 2x is equal to plus 10, x is equal to plus 5. Next one, Al2O3 2x is equal to plus 6, x is equal to plus 3. Next one, Hg2S underlying element 2 into plus 1 plus x is equal to 0, x is equal to minus 2. So it is in decreasing order. So plus 5 greater than plus 3 greater than minus 2. So your option 2 is the correct option. Okay students. Next one, question number 80. Question number 80, they given, consider the reversible equation. Whenever reversible equation, you can remember work done reversible reaction is equal to minus nRT ln V2 by V1. Remember this equation. Now coming to the first process. In this first process, P1 to P2, V1, V2 they given. Now you can write the equation. W is equal to number of moles 1 mole given. So 1 mole you can substitute. 1 R value they given 2 calories. 2 temperature T ln V2 by V1. So you can write V2 by V1. So your answer is minus 2 T ln V2 by V1. This is at temperature T1. So this is the graph 1. So now graph 2 you can see step 2, these are adiabatic. Adiabatic means what? Work done is 0. So that's why you have to consider only W1. W2 case it is 0. Now you can take the W3. W3 in this case you can take. So here V3, V4 given, T2 temperature remains same, T2 isothermal. So minus NR T2 ln V4 by V3 you can write. Now you can say here minus N value is remains same, minus N value you can see. Here they mention the process, the work done in the process like 1, 2, 3, 4 like that they mention. So here the number of moles is 1, R value 2, T2 ln V4 by V3, that is equal to minus 2 T2 ln V4 by V3. V4 work done in adiabatic process, so that is 0. So finally if you add these two, W1 plus W3 is equal to minus 2 T1 ln V2 by V1 minus 2 T2 ln V4 by V3. So this is the final equation. The answer is 2. Next one, coming to the point, question number 81. For ideal gas equation, delta H and delta V is 0. We know about that. For ideal gases equation, delta H and delta V is equal to 0. And now no interaction occur between the molecule because the ideal solution P and Q intermolecular forces almost equal. Intermolecular forces almost equal here. So the given statement is wrong. The given statement is wrong. Okay. So the option is, first option is correct and second option is incorrect because there we have the similar interactions. Some type of interactions are there. They told no interaction, but actually some interactions present in ideal solutions. Okay, between the ideal solution some interactions are present, almost same, but they given no interaction. That's why the second statement is incorrect. Now coming to the question number 82. Question number 82, you can check the number of unpaired electrons. Based on the number of unpaired electrons, you can identify. Let's take titanium. Titanium oxidation state plus 3. Titanium atomic number you know. Scandium, titanium 4s2 3d2. So titanium plus 3 means 3d1. We have only one unpaired electron. For example, if you take the manganese. Manganese oxidation state plus 3. Manganese oxidation state. Manganese atomic number 4s2 3d5 plus 3 means 4s0 3d 3d3 3d4. Okay, plus 3 means. So we have the 4 unpaired electrons here. 1, 2, 3, 4 unpaired electrons, but the field, strong field ligand is present. Here we have the strong field ligand. So because of this strong field ligand, we have filling of electrons like this. 2 unpaired electrons are there. So because of this unpaired electrons, the magnetic moment mu is equal to root over n into n plus 2, that is equal to root over 2 into 2 plus 2, that is equal to root 8. So this point you can remember. Similarly, if you take the electron, third option you can take Fe plus 3 oxidation state. That means it has the electronic configuration 3d5, but it is cyanide is a strong field ligand. Strong field ligand pairing takes place. So you have only one unpaired electron. So among the given options, if you consider the cobalt NH3 taken 6 times plus 3. So here cobalt plus 3 means cobalt means 4s2 3d7 plus 3 means 4s0 3d6. So it is a strong field ligand, so pairing takes place. So there is no unpaired electron here. Final conclusion, first one has one unpaired electron, here two unpaired electron, here one unpaired electron, here zero unpaired electron. So you have the more magnetic moment in manganese, second option. 82, option 2 is correct. 83, a protein undergoes reversible denaturation process, and at equilibrium they mention standard enthalpy change, standard enthalpy change they given 666 kilojoule per mole, and the standard entropy change they are asking, and they given the temperature is equal to 60 degrees 273, that is equal to 333 Kelvin. So the formula, remember, at equilibrium delta G is equal to delta H minus T delta S. Delta G is equal to 0 at equilibrium, delta H is equal to T delta S. Therefore, delta S is equal to delta H by T. Delta H is equal to 666 by 333. Finally, you will get 2 kilojoule per mole. So your option is 2. For 83 question, option 2 is correct. For 84, the question is, generally 3D transition elements has high melting point. Okay. So yes, when compared to S block element, P block element, D block elements has more melting point. They are comparing the transition elements along with the S and P block element. And involvement of 3D electrons in addition to 4s electrons, because of metallic bonding, that melting point increases. So both options are correct, and R is the correct explanation for assertion. Reason is the correct explanation. So option 2 is correct. 85. The first ionization enthalpy of oxygen lower than nitrogen and oxygen. Yes, oxygen electron configuration 2s to 2p4, nitrogen electron configuration 2s to 2p3, half filled, and fluorine electron configuration 2s to 2p5. So in period left to right, what happened? Atomic radius decreases. So atomic radius decreases, ionization enthalpy increases for fluorine. But among nitrogen and oxygen, based on the half-filled electronic configuration, nitrogen is more than oxygen. So the first ionization enthalpy of oxygen is lower than fluorine and nitrogen. The loss of an electron from oxygen lead to stable electronic configuration. Correct. So both are correct. So 85, option 2 is correct. Both are correct explanation. Question number 86. They given the compound pH C triple bond C methyl group, CH3 group is there. It react with sodium in liquid ammonia. Sodium in liquid ammonia, it is a Birch reduction. So here it undergoes reduction to form transalkene. CH, pH, C double bond, CH, CH3 will come. Now this one, this is Linder's catalyst. Linder's catalyst undergoes cis addition to form cis alkene, like C double bond, hydrogen, pH, CH3. This is the compound L, this is the compound M. So L, M, one is cis, same side addition, one is trans, opposite side addition. So this is called cis and this is trans. These are stereo isomers or geometrical isomers. These are geometrical isomers. Okay. Now, if you react with HBr in the presence of benzoyl peroxide, if they mention that is anti-Markovnikov rule, according to anti-Markovnikov rule, based on the mechanism, free radical mechanism, you will get the compound like this: CHBr, CH, hydrogen, CH3. Now this is HBr. According to Markovnikov rule, negative part attached to more stable carbocation, pH, CH, Br, and then you will get CH, CH3. Okay. So now you can see M and R stereoisomers. No, M and R structural isomers, and K, L are geometrical isomers. So these are geometrical isomers. First they are given about the K compound and L compound, both are geometrical isomers. This is the option number 2. Now question number 87, the highest molecular orbital neon twice. You know pi star 2px 2, pi star 2py2, sigma star 2pz2. This is the highest occupied molecular orbital. Highest occupied molecular orbital. This is option number 1, question number 87. Question number 88, PCl5, sp3 to hybridization, trigonal bipyramidal. So A is 3 and BRF5 is the square planar because of one lone pair, 6 bond pairs. So it is a square pyramidal shape. Square pyramidal shape. BRF5 is the square pyramidal shape. BF4 tetrahedral because of tetrahedral it is a sp3 hybridization, and nickel tetracyanide it is DSP to hybridization square planar. So your answer A3 B3 A3 B4 A3 B4 option C1 and D2. So your option is option 3, PCl5 trigonal bipyramidal, BRF5 square pyramidal, BF4 minus tetrahedral, Ni tetracyanide square planar. Okay, option 3 is correct. Next one, 89. Sources they are given the different question. Vitamin A, carrot. Vitamin B12. Vitamin B12 is green leafy meat, remember. Vitamin B12 is meat, and vitamin E is the sunflower oil, and vitamin K is the green leafy vegetables. So find the option is 89, 3 option. Next one, 90. This is a different model question. This is benzene. Benzene on acylation, CH3COCl, AlCl3, you will get the compound S2-phenone, C double bond O CH3. After that they given NaOCl. NaOCl, you know NaOI if they mention, that is iodoform test. NaOCl this is mentioned, that is chloroform test. So finally after chloroform test you will get benzene upon COONA, and here iodoform you will get. After that this compound on hydrolysis you will get the compound benzoic acid. This compound on oxidation you will get COCl2, that is carbonyl chloride, which is the poison. Now they given like this. P gives carboxylic acid and acidification. Yes, actually P is the sodium acetate, sodium benzoate and hydrolysis you will get the compound benzoic acid. Next one, chloroform on oxidation get poisonous gas carbonyl chloride. So option 4 is correct. So this is about the RE NEET question paper, students. Thank you very much.